What is nuclear fusion and why does it happens? So in this video we are going to learn about nuclear fusion that happens inside the sun, so why delay, let's begin the video. Nuclear fusion is a reaction through which two or more light nuclei collide into each other to form a heavier nucleus. This reaction takes place with elements that have a low atomic number, such as hydrogen. Both nuclear fusion and fission produce a massive amount of energy. In other words, nuclear fusion, process by which nuclear reactions between light elements form heavier elements, up to iron. In cases where the interacting nuclei belong to elements with low atomic numbers, e.g., hydrogen atomic number 1 or its isotopes deuterium and tritium, substantial amounts of energy are released. The vast energy potential of nuclear fusion was first exploited in thermonuclear weapons, or hydrogen bombs, which were developed in the decade immediately. Proceeding further, let's see how does fusion reaction happens. Fusion reactions constitute the fundamental energy source of stars, including the sun. The evolution of stars can be viewed as a passage through various stages as thermonuclear reactions and nucleosynthesis cause compositional changes over long time spans. Hydrogen burning initiates the fusion energy source of stars and leads to the formation of helium. Generation of fusion energy for practical use also relies on fusion reactions between the lightest elements that burn to form helium. In fact, the heavy isotopes of hydrogen, deuterium and tritium react more efficiently with each other, and, when they do undergo fusion, they yield more energy per reaction than do two hydrogen nuclei. The hydrogen nucleus consists of a single proton. The deuterium nucleus has one proton and one neutron, while tritium has one proton and two neutrons. The energy from the sun, both heat and light energy, originates from a nuclear fusion process that is occurring inside the core of the sun. The specific type of fusion that occurs inside of the sun is known as proton-proton fusion. Inside the sun, this process begins with protons, which is simply a lone hydrogen nucleus, and through a series of steps, these protons fuse together and are turned into helium. This fusion process occurs inside the core of the sun, and the transformation results in a release of energy that keeps the sun hot. The resulting energy is radiated out from the core of the sun and moves across the solar system. It is important to note that the core is the only part of the sun that produces any significant amount of heat through fusion. It contributes about 99%. The rest of the sun is heated by energy transferred outward from the core. Steps: the overall process of proton-proton fusion within the sun can be broken down into several simple steps. A visual representation of this process is shown in Figure 1. The steps are: two protons within the sun fuse. Most of the time the pair breaks apart again, but sometimes one of the protons transforms into a neutron via the weak nuclear force. Along with the transformation into a neutron, a positron and neutrino are formed. This resulting proton-neutron pair that forms sometimes is known as deuterium. A third proton collides with the formed deuterium. This collision results in the formation of a helium-3 nucleus and a gamma ray. These gamma rays work their way out from the core of the sun and are released as sunlight. Two helium-3 nuclei collide, creating a helium-4 nucleus plus two extra protons that escape as two hydrogen. Technically, a beryllium-6 nuclei forms first but is unstable and thus disintegrates into the helium-4 nucleus. The final helium-4 atom has less mass than the original four protons that came together, Ce equals mc2. Because of this, their combination results in an excess of energy being released in the form of heat and light that exits the sun, given by the mass-energy equivalence. To exit the sun, this energy must travel through many layers to the photosphere before it can actually emerge into space as sunlight. Since this proton-proton chain happens frequently, 9.2 x 1037 times per second, there is a significant release of energy. Of all of the mass that undergoes this fusion process, only about 0.7% of it is turned into energy. Although this seems like a small amount of mass, This is equal to 4.26 million metric tons of matter being converted to energy per second. 3. Using the mass energy equivalence, we find that this 4.26 million metric tons of matter is equal to about 3.8 x 1026 joules of energy released per second. So to understand the concept more clearly, let's watch a small video with respect to the nuclear fusion that happens in the Sun. Thank for watching the video. I hope you understood about the nuclear fusion process.